Number 5, block of ice here at, at 0 degrees Celsius sits on the counter and begins to melt. How much energy must be absorbed by the snow? I think it means the block of ice when it's all melted. Well, let's do it here. Time and temperature. And this is at 0 degrees Celsius. I'm just going to put 0 up here so we can see it. Now it's melting, and when there's a phase change, the temperature doesn't change because the energy is being stored as phase energy. So we've got a plateau here. I think we're going to use this equation. Q, we don't know. M is 200 grams times C. Okay, this is a block of ice that's melting. Is it a liquid? Well, it's going to be at the end, but during the process of melting, no, we're not going to use this constant. Is it a solid? No. It's evaporating, condensing. No, it's melting, so we're going to use this one, the heat of fusion, and that is 334 joules per gram. Now remember, temperature is not changing, so we're going to cancel out this value here and solve. 200 times 334 gives us 66,800. Grams cancels with grams, so we're left with joules. All right, let's look at the number of sig figs here. 3 here, 3 here, so I get 3. Oh, well, here are my 3. Q is equal to 66,800 joules. Final answer. No rounding here because this has 3 digits just like these 3. These have 3. Number 6, piece of gum provides 5,000 joules when digested by your body. The same amount of energy would transfer to 100 grams of water at 20 Celsius. What would the final temperature be? Oh look, it's another one of these where we're trying to find the final temperature. Here's our curve here. This is time. This is temperature. This starts at 20 degrees Celsius. And we don't know where it goes to, but we know it increases because the energy is being added. Okay. Q equals M times C times delta T. Our mass is 100 grams. Our energy constant is, the water's at 20, so it's going to be a liquid. So it's 4.18 joules per gram degrees Celsius. Times delta T. We know it starts at 20, but we don't know what it goes to, so delta T. All right. 100 times 4.18. Look, I'm not going to fall for it. I'm going to do it in my head this time and get 418 joules per degree Celsius times delta T equals Q. Oh my gosh, I didn't plug in Q. Q is 5,000. So if this was in class, one of you would have stopped me. Look, this is 2 variables. I can't solve for 2 variables here. I'm just getting lazy. 5,000 equals 418 times delta T. So where I'm getting that 5,000 is right here. It plugs into Q. Now I divide both sides by 418. 418. Cancel, cancel. 5,000 divided by 418. Probably can't do that one in my head. It is delta T equals, I'm just going to write my calculator, 11.9617, blah, 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 blah. All right, how many digits do we get to keep here? Well, this one has 4, this one has 3, so we're going to keep 3. And so we get the 11.9, but this 6 rounds the 9 up to a 0, so this just becomes 12 is our delta T. 12 degrees Celsius. Well, that's our change of temperature. We need to find our final temperature. And if we're starting at 20, and we know it changes by 12 degrees Celsius, well, and we know it's increasing because we see that the energy is being added here, so we know the change here, it grows by 12 degrees Celsius, so it must go to 32 degrees Celsius, because 20 plus 12 is 32. I realize I forgot to do that adding on this problem here. Number 4 So make sure you add your answer to 20 so that you can find the final temperature as well. Well, that wraps up the Unit 3 review video. Thank you for watching. Remember, during this video, you can always rewind or pause to make sure you understand the most important concepts. Otherwise, feel free to contact via Edmodo or during passing period, and good luck on your exam.